Hello everyone, myself Dr.B.Srimathy, Assistant Professor, PG and Research Department of Physics, Sita Lakshmi Ramasamy College, Tiruchirappalli. So this lecture is about crystal defects. So before knowing what is crystal defects, we should understand what is a crystal. Crystal is always a name which is fascinating for people because of its appearance. So what is a crystal? Crystal is a solid whose atoms are arranged in a highly ordered repeating pattern. We can see some pictures of different crystals, quartz, salt and ice. So the outer appearance looks like this, but whereas the inner side of each crystal is looking like this. So all solid materials are made up of atoms. So inside them, these atoms are highly orderly and arranged in a repeating pattern. So quartz crystal consists of silicon and oxygen atoms arranged in some pattern like this. Similarly, a salt crystal and ice crystal are also having some orderly arrangement of atoms. So the inner side of a crystal is looking like this. So what happens when this orderly arrangement gets disordered or gets distorted? Then it results in a defect. So why these defects are important? So defects are important because they control a lot of properties in the materials. There is a famous saying by a scientist called Sir Colin John Humphreys. So he's a material scientist. He compares people with crystals. He said, crystals are like people. It is the defects in them which tend to make them interesting. So we know that people are not the same. So some people are shorter, some people are taller, some people are thin, some people are fat. So people differ from each other. Similarly, crystals also differ from each other by their properties because of its inner arrangement of atoms. So what are the properties it generally affects? So electrical conductivity, thermal conductivity, ionic conductivity, diffusion, plastic deformation, color and mechanical strength are the major properties which are affected by the arrangement of atoms inside the crystal. So what are crystal defects? Crystal defects are nothing but the irregularities on the lattice. That is, any deviation from the perfect geometrical arrangement of atoms in a crystal results in defects. So these defects can be classified into four types: point defects, line defects, surface defects and volume defects. So there are some inner classifications for all these which we will be looking into detail in the later slides. So first we will understand what is a point defect. So point defects are zero-dimensional defects. So which means that the irregularities are the defects are of atomic size dimensions, that is point size dimensions. So whenever the imperfect point-like regions are present, then we call them as point defects. So these point defects can occur in non-ionic or ionic crystals. So if it is present in non-ionic crystal, it can be either a vacancy, interstitial or an impurity. Whereas if it is in an ionic crystal, it can be either a Schottky or a Frenkel defect. So first we will see in detail about the vacancies and interstitial defects. So these two are called as intrinsic point defects. So what is these intrinsic point defects? So in the case of a vacancy, we could see that all these are blue colored circles represent the atoms, the position of atoms in a lattice. So here we could see that there is an empty space, which means that this atom in this place goes missing. So if one or atoms goes missing from its place, then it is called as a vacancy defect. Whereas in this picture, we could see that one atom is occupied in the interstitial site. So the same atom present in the parent lattice is occupying an interstitial site. So this we call it as a self-interstitial. Next one is impurity defect. So this is a extrinsic point defect. So impurities are nothing but the foreign atoms which are added to the crystal lattices. So here we could see that there is a red atom which is occupying the parent atom site. So that is, it is going and replacing the parent atom site, or it is going and substituting the parent atom site. So this we call it as a substitutional impurity. Whereas here we could see that the foreign atom is going and replacing the interstitial site, or it is going and occupying an interstitial site in the parent lattice. So this we call it as an interstitial impurity. Next is the ionic crystals, the defects in the ionic crystals. So ionic crystals, as we know that it consists of cations and anions. So whenever a pair of cation and anion goes missing, then it is called as a Schottky defect. So here in this picture we could see that a positive ion and a negative ion both goes missing here and vacancies are created. So this kind of defect we call it as a Schottky defect. So this occurs mostly in sodium chloride and potassium fluoride. So whereas in a Frenkel defect we could see that a positive ion goes missing and creates a vacancy, and this positive ion goes and sits in the interstitial site. So a vacancy and an interstitial deficiency is created. So this kind of defect we call it as a Frenkel defect, and this usually takes place in calcium fluoride and AgI. Line defects. So these are one-dimensional defects. So these defects are nothing but when a line of atoms goes missing or displaced from its regular site. So these are usually called as dislocations. So these can be classified into two. One is edge dislocation and the other one is screw dislocation. So in an edge dislocated crystal, we could see that there is a line of atoms goes missing in the lower half of the lattice. So here we could see that the upper half contains this line of atoms, whereas this goes missing in the lower half. So this you call it as a dislocation line. And this can be classified into two. One is a positive edge dislocation and the other one is negative edge dislocation. So positive edge dislocation is where the line of atoms is present in the upper half and it goes missing in the lower half. Whereas here in the negative edge dislocation we can see that the line of atoms is missing in the upper half and it is present in the lower half. Screw dislocation. Screw dislocation is where the displacement of atoms in one part of the crystal is relative to the rest of the crystal. So here we could see that this is one single crystal, but part of this crystal is looking like this, and this part of the crystal has totally distorted from this part. So this kind of distortion we call it as a screw dislocation, and usually it looks similar to the threads of a screw. Burger's vector. Burger's vector is a vector which is represented by a small letter b, and it usually gives information about the amount and direction of shift in the lattice on the slip plane. So here in the edge dislocated crystal, this red color arrow represents the Burger's vector, and here in the screw dislocated crystal, this red color arrow represents the Burger's vector. Next is about the surface defects, which are called two-dimensional defects. So it can be either grain boundaries, twin boundaries. So grain boundaries, it is nothing but the interface between two grains with different crystal orientation. So here we can see that there is one crystal orientation and this is another crystal orientation, and there is a boundary between these two which separates these two, and this kind of grain we call it as a grain boundary. So here we could see that there is a twin boundary where the atomic arrangement on this side is exactly the mirror image of this side, or the mirror image of this side can be the exactly same mirror image of this side. So these two are the mirror images of each other, and in between these two we have a boundary, and this we call it as a twin boundary. Another type of surface defect is stacking faults. So here the sequence of the atoms is not in a proper manner. So whenever the stacking of atoms is not in a proper sequence, then it results in stacking faults. So here we could see the picture of a perfect crystal. So the sequence is like CBA, 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 it goes on. So that is blue, green, red, blue, green, red, blue, green, red, it goes on. So this is a perfect crystal. But whereas here, if there is a fault in the crystal in the sequence, so like ACB, ACB, A. So here this A line of atoms is missing. So after B there is a C line of atoms. So here we can see red, blue, green, red, blue, green, red. So red is missing here. So there is a sequence change. So this kind of stacking sequence, if it is or disordered, then we call it as a stacking fault. Next is about volume defects. So volume defects are also called as bulk defects, and these are three-dimensional defects, and they tend to change the properties of crystal a lot. So this can be either dispersants, inclusions, voids, or cracks. Dispersants are nothing but small microparticles which are distributed throughout the microstructure, and inclusions are nothing but larger precipitate particles or foreign particles present in the lattice, and voids or cracks are nothing but the cluster of atoms missing. So here we could see some pictures of volume defected crystals. So where we can, at the center, the atoms are arranged in a disordered manner. So here also at the center, the atoms are arranged in a disordered manner, or some foreign atoms are present here. And here at the center, a large number of atoms goes missing. So this kind of defect will also contribute to the bulk defects. And here is a picture of a SEM image, that is a scanning electron micrograph of a thin film, that is chemically vapor deposited gallium nitride thin film. So the surface of the thin film looks like this as seen through the micrograph. So here we can see that there are large number of pits and grooves on the pits and pores on the surface. So the enlarged image looks like this. So here we could see the groove goes deep into the film, and it is this pit is going on extending into the film. So this kind of pits, when it is present larger in number on the surface and it is deep enough, then it will definitely contribute to the property change in the crystal. So this is about volume defects. So today we have seen about the different types of crystal defects in crystals. So thank you.